Morning, wherever you are, people from all around the world. Welcome to the World Potato Congress webinar. Before we start, just as a short reminder, I remind you about that you are all welcome to join the World Potato Congress, the 11th, that will be held in Dublin in May 22 and the end May 30, 2022. In Dublin, Ireland. And without further ado, let's progress. My name is Yechiam. I'm from the irrigation company of Netafim. And today's topic, hosted by the World Potato Congress, is basics of potato irrigation and irrigation scheduling. Relatively shortly about who I am. Okay, so you can see me here. This is from a field in Idaho, where I'm installing soil sensors in one of our potato trials. My name is Yechiam. I've been working for the past 5 years for Netafim Irrigation Company. This is my email address in case you have sort of questions after the presentation. You can also look for me at LinkedIn and connect. My main interest professionally are digital agronomy, crop models, sensor solutions, also potatoes. And another thing that I like very much, I can talk about for hours, is basketball. So if you have questions about this also, you can connect with me, no problems. And let's jump into the water. So what we're going to talk about today, first of all, we're going to talk about the importance of irrigation. Briefly, we all know it's important, but we're going to see how. Secondly, we're going to talk about irrigation methods. We're going to score for them, what irrigation methods we have, and so on. Then we're going to dip inside and talk about the big main issues when talking about irrigation scheduling, which is how much to irrigate, but also when to irrigate it. And on the time that we'll have left, we're going to talk about digital farming solutions for optimization of irrigation. So the first topic, the importance of irrigation. Let's look at this graph. Now, basically what we're talking about, you can see here the potatoes. Potatoes are in between, the drought sensitive resistant. It's not as gentle or sensitive as lettuce, but on the other hand, sorry for that. On the other hand, it is not as resilient or resistant as a cotton field. It's kind of in the middle within its drought resistance. So we have to irrigate it. It will not fall apart if we don't give him water on time. But if we go on this graph on the left, you can see here, this is a graph adapted from the FAO aquacrop model, which we also been dealing with. Here you can see on the x-axis, you can see soil water from field capacity to permanent wilting point all around. And over here, you can see the coefficient of canopy development. And you can see, and don't mind the values from that point, but you can see that starting from a 20–30% of soil depletion, you will start to lose canopy development, hence start to lose plant development, reproductive, and yield at the end of the day. So you have to maintain aqueduct soil moisture, otherwise you will lose your canopy development. Your canopy will develop much less than it should, and you will lose yield. If you proceed, we have this graph. This one ties up between soil water or available soil moisture and stomatal conductance, and you can see that starting from a very point of around 40–45%, you are starting to experience, if you don't replenish the water in your soil moisture, in your soil root zone, you will start experiencing stomatal conductance failure. They will conduct less water, transpiration will be lowered, and so on, and therefore yield, and on top of it, actual profit at the end of the day will be diminished. So there is a clear relationship between those two parameters. We can also look at this graph adapted from Professor Clinton Shock et al. From the Oregon State University. Talks about the potato yield and quality in response to deficit irrigation. You can see here that there is a clear correlation between water applied. It can be rain and it can be also by irrigation and the actual yield at the end of the day. And on the top of the day, it all comes down to the profit that you make. If you apply sufficient water, again, it can be irrigation. And if you are lucky enough, it can be by rain or part of it by rain. Then the profit is directly connected to your applied irrigation per season. So we all know it, we all understand of it, but it's always important to go through on it, to go back on the numbers. Now let's talk briefly about the irrigation methods that are available for us. Most of the potato regions, even if grown on in a rain-fed areas nowadays, especially with the climate change that is going on, need to irrigate. Maybe only more, maybe a few times a season, but they do need to irrigate. We see it more and more all over the world. And basically, we can divide the irrigation methods available for us as potato industry people to three main methods. The first one is the overhead, the rain guns, which is common mostly in partly rain-fed grown potato territories, the pivots, some places call the boom, and the sprinkler irrigation. We have the flood irrigation, which is very, very ineffective. But when I was searching for material for this presentation, it is still the most common irrigation method around the world in potatoes, the flood irrigation. And you have the localized irrigation systems such as drip or subsurface drip irrigation, the SDI. And by the term localized, it means they do not wet the entire surface or they do not wet the entire area. They are more localized, more close to the plants, and so on. So those are the three main irrigation methods. And doing a sort of a drill down of, the pros and cons of each irrigation methods. Now, from a lot of experience around the world, there is no one irrigation system that fits all cases. In some cases, drip would be the most portable one. In some cases, flood. And each system has its own unique situation that you can play along with it. Of course, flood, is the most low one with water use efficiency, labor uniformity, the ability to fertigate, to fertilize, and so on. Its main con is it is the most cheapest one. Overhead irrigation system have their own pros and cons, and again, each situation might bring us to think of a different irrigation method. It's all a matter of plot size, wind, and you have this table. We will not go through on it. This table that sums up all pros and cons. And I think on the top you have drip, which is with some maintenance and labor required, especially at the beginning, but has some different objectives, some different advantages when, especially regarding water use or nitrogen use efficiency, preciseness, and so on. And again, we are not going to go through this table, but this presentation, this slideshow should be available for you. So we will share it with you, and you can go through each system. Now I'm going to expand a little bit about the drip irrigation because it raises a lot of questions around the world, especially around the world of potatoes. So I'm going to expand within those irrigation methods that I mentioned. I'm going to talk a little bit about drip irrigation before we go into irrigation scheduling. So basically, we recommend of two main configurations between ridge to lateral. The first one is 1-to-1, which means, like you can see in the picture, that for each ridge of potatoes, you place one lateral of drip irrigation. And the second very, very common option that we are using is the 1-to-2, which means one lateral for two ridges. As you can see here, you can see it in a more, here you can see it in a more graphical way. This is the 1-to-1. You can see one lateral per drip. This is the sub-main, by the way. And this is the 1-to-2. Between the two ridges on the sidewalk, you place one lateral. And now let's go, again, this slide is very detailed. It gives you the right different cases, different technical situation between the 1-2 and 1-1. But basically, if you ask me when to place 1-2 and when to place 1-1, so if talking about 1-2, if you are growing in a rain-fed areas, but you still need to irrigate 5, 10, 15 years a season, like in 2020 that we had, you are going from processing and you're medium to heavy soil, or you are seed potato producer, then this must be the perfect solution for you. It's also a bit easier laying down the drip and recoiling at the end of the season. So this is the consumption. And the second case and the solution of 1-1 is basically if you are going processing potatoes, you're aiming for either high yield, either high quality, high uniformity. You want to press it on. You're growing on a sandy soils, and also you have 0 to very low rainfall area. Then 1-1 is the solution that you might want to choose. And again, every case, every scenario, every field, every plot, every grower is a little bit different. And what irrigation method or when talking about drip, what irrigation configuration should differ between one scenario to another. This is just really big thumb rules we're talking about. Also, I was asked to explain about drip irrigation. So regarding machinery, drip do need to be laid down at the beginning of the season and recoiled before harvester. So today there are various number of machinery solutions that are available for each scenarios, for large plots, large growers, small growers, and so on, in big differences. And again, you can contact the relevant people and they can advise you, but the solutions do exist. We know the most big companies in the field of agro machinery that you guys are familiar with. Now, after we talked about the importance of irrigation in potatoes, we saw some example. We talk about and we search the irrigation methods that we are talking about. Now, let's try and go deep about irrigation scheduling in general and in potatoes. Now, when talking about irrigation scheduling, we're talking about mainly two principal questions: how much to irrigate, and the second one is when to irrigate. Okay, and basically, if I want to know how much to irrigate, all I need to know is three very simple questions. One, I need to know my crop phenology and the water requirements relevant for each phenological stage. Important. Two, I need to know my soil and my soil characters and how much water can it hold for me. And three, very crucial, I need to know my climate. As localized as I have this data, I'm more accurate. How much to irrigate? So you're going to see this graph again today. I irrigate according to plant needs, which is the ETC. Of course, I guess a lot of you are familiar with this simple equation. My ETC, my crop water requirement, is consisted with two parameters. ETO, which is an climatic parameter derived from evaporative climatic parameter, such as solar radiation, wind velocity, temperature, relative humidity. Of course, if it's hot and dry and it's a long day, many hours of light and radiation and very windy with dry winds, then my ETO would be high, about 7, 8. We experience even 10 millimeters and more back in Israel. So this is an evaporative demand. We will talk about it. And this one, my KC, my crop coefficient, is the ratio that I give to determine the actual crop water requirement. And it derived from my phenological situation, my canopy development, my yield level, and so on. We will talk about this as well. At the end, I get the ETC, the actual crop evapotranspiration. Okay, let's start with the ETO. We told you it's an evaporative, it's a climatic parameter. In the past, in some places we still do it. We would get it from this evaporation pen. You come at the end of the day, you measure how much millimeters of water were evaporated to the atmosphere, and you measure it, and this is your daily, in millimeters, your daily ETO. And today you have two very good solutions. One, there are many apps and web services that you can download it. For example, like this application, What's My ETO, you can download it to your cell phone from wherever you are in the world and start get your daily ETO data. The second one, the more accurate one, but fairly much more expensive, is to purchase a weather station and start getting your data, place it in the field and close to the farm, close to the office, and start getting daily ETO data and also other parameters such as rain, humidity, temperature, and so on. As more as you go down this road, you are more accurate and you can schedule your irrigation more accurately. Now, let's talk a little bit about the crop coefficient. Basically, it consisted of two main particles. Ke, which is the soil evaporation coefficient out of soil, and K transpiration, which comes from the green parts of the plant, in this case, the leaves of the plant, the transpiration piece. Now, let's look at this schematic graph. Okay, we have a 120 days of processing potatoes. We planted on day one. There are no canopy development. So we have only the blue part, the K evaporation is on that point. Once establishment has occurred, emergence has occurred, okay, and plant and starting to establish, you see that the K transpiration coefficient is rising up, while the K evaporation part is going down and decreases all the way down until almost zero, okay? Now let's go back to the K transpiration particle. You can see it develops parallel to the plant canopy development until the close of the row, the close of the canopy, okay? And from that point, it starts to be on a permanent level all the way through, or most of the way through the reproductive phases, the yield producing periods of the plant, and during the end of towards the end of the crop cycle, the crop growth, when canopies start to senesce. So we have a decrease in K transpiration all the way down and a slight elevation back over again because of the canopy senescence for the evaporative particle. So this is what we are doing here. This is just a schematic graph, but it brings this method. And let's talk about our crop protocol. This is for medium cycle, 120 days processing potatoes. Of course, if I would talk about seed potatoes, I would have different numbers, slightly different. And each stage is represented with some kind of graphic presentation, a default value of its duration, but of course, it changes according to local climate and so on. And on this row, you have the KC, the relevant crop coefficient, and you can see the during sprout development, you start with 0.5. Then on the vegetative growth, this is for potatoes particularly, okay? Those 30 days, it goes from 0.5 to 0.75. Then it still continues to develop its canopy further due. But another thing that it is added to this part, that we are also starting to initiate our tubers, right? So we need to pay for two meals, basically. One for the canopy that is still being developed, and secondly, for the initiation of the tubers. So we are starting from 0.75 all the way up to 1.1, which is a little bit higher than a full canopy field. It's a little bit more. And then during bulking stage, we can either, some growers leave it, the coefficient on 1.1 for the entire period. We have our own knowledge that you can diminish, especially when using drip irrigation. You can reduce the ease of the water all the way down to 0.8 during those 35 days. And during maturation phase, also you can see that the canopy is beginning to senesce. You can drop down from 0.8 to 0.4 all the way down until the stop of irrigation and they are wait for the harvest. So this is basically, and again, those are numbers, it varies a lot between varieties and locations and so on. But this is the basic pattern of the crop coefficient of the potato, 120 days of processing potatoes. Now let's do a short calculation example. Let's say we planted at Idaho at the middle of April. So at July, we're at the peak of the tuber initiation stage, okay? So our crop coefficient is 1.1, is the most highest one in the point. And at July, the daily average evapotranspiration from my weather station in millimeters, it's 5.9 millimeters. Then my daily irrigation would be crop coefficient times ETO times the evapotranspiration, which is 6.5 millimeters per day. So if I would irrigate every day, that would be my irrigation. Of course, if I don't know, I can, from hydraulic reasons, I can irrigate only every 3 days, then I have to take this value, which is average one, and multiply it by 3. And every 3 days, I have to apply 19.5 millimeters of irrigation. Okay, so basically, it's a very simple and example, but this is what we're talking about. But the main questions is also another question is when to irrigate. Okay. Now, before we start to talk about when to irrigate, of course, in life, what determines when to irrigate is not, sometimes it's not agronomy. It's not how you do it, or when it's correct agronomically to irrigate. Sometimes you have hydraulic limitations. Sometimes you have operational limitations. Sometimes you spray and you don't want to irrigate the day after. Sometimes your pump broke down. It's Sunday and you want to get some rest. You know, all of those things are available. But now we're going to talk about when is optimally the optimal time to irrigate agronomically. So how do I irrigate? That's easy. I irrigate according to my soil type. And before we dig into this, let's look about this table. You have it's adapted from the FAO, the USDA classification of soils. Each soil has its bulk density, its volumetric water content, on saturation, on field capacity, on permanent wilting point, and the very important parameter derived from it, the tau, which stands for total available water. Okay, you can go through the numbers, and you can see in the graph here on the right, you know, the boundaries between built-in point and my field capacity. This is my 100% of available water. Okay, now let's try to think of it as a swimming pool or a reservoir or something like this, which when you're the water that your swimming pool holds is the amount of water from the top at the field capacity all the way down to the permanent wilting point. This is your stored available water. Think of it as a reservoir, one-dimensional reservoir in millimeter of water. And let's do a short calculation. Let's look at two opposite soils. Let's talk about sand, okay? You can see that my volumetric water content is 13% at field capacity and 6% on wilting point. The delta between them is 7%. I divided by 1,000, do sort of a unit change. At the end of the day, I have in 1 meter of soil, if I dig 1 meter of soil, I have 70 millimeters of stored water available for my plants. On the other hand, let's look at the clay soil. You can see from the table, we are on 54 at field capacity, 39 on wilting point. That's a difference of 15%. Again, doing the field capacity minus wilting point times 1,000 to go to the right units. So in 1 meter of soil, we have 150 millimeters of water, almost more than double than this. So this is my total available water. But basically, on plants, we need to know another term, which is the effective tau, the effective total available water, which relates to my effective root zone. Let's look at these two crops, onion on the left and potato on the right. They are both grown usually in the same areas. You know, you can see in many places potatoes and onions. So let's say I have the same soil. On half of it, I grow onions. On the second half, I grow potatoes. It's the same tau, same water holding capacity, but effective root zone for a very, very shallow rooting plant such as onion is 30 centimeters, while in potato, and we've experienced it, we're talking about half a meter usually, 50 centimeters. So the same soils in 1 meter times the actual depth of the root zone, of the effective root zone, you can see that on onion, you are talking about a relative available swimming pool of 45 millimeters of water, while we're talking about 75 millimeters of water when talking about potatoes. And how do we get those data? So usually we do a lot of those tests, and this is an example from the potatoes. You can see here that the majority of the roots are within the top 35, maybe 60 centimeters. Also, 50% of the roots almost are in the top 30 centimeters. So this is about it. So we take into account that on a grown, mature, during tuber initiation stage, the potatoes, we're talking about 50 centimeters of soil, of rooting, of depth rooting zone, sorry. So this is the idea. And before we dig into a little bit into calculations, let's meet another important parameter, which is the depletion threshold. It can be in percentage. Sorry. It can be in percentage. It can be also in millimeters or inches. And when talking about this, my depletion threshold is a point between field capacity and wilting point, which I don't want to go below this point. If I go below this point, as we saw at the beginning when we spoke about the importance of irrigation, I start to affect my canopy development, my stomatal closure, and so on. And I'm starting to lose yield and money at the end of the day. So before we dig into calculation, let's talk about this allowable soil depletion of potatoes. We are going back to 120 days processing potato cycle. So you can see that during the early stages, I can allow my soil to be depleted for 30%. Also, because at this stage, I want to allow my plants to search for the water in the soil and grow roots for that in order to get a good anchor at the field. But once I go into the two delegate stages of initiation and bulking, I don't want to go below a certain threshold. So I raise it up. I raise my line to 20%. And during senesces, I can ease up my my depletion threshold and go back to 30%. Of course, the interval, which combined with the ETC, will be much shorter. If here in a medium soil, I would irrigate under the Idaho conditions every 3 to 5 days. So at this stage, between every 2 to 4 days, optimally. And here I can go back to every 4 to 6 days, 2 or 3 irrigations a week, just in a rough numbers. Sorry. So here is an example of how to calculate irrigation interval. You know, we have a time limit, so we are not going to go through all of those numbers again. But those are two soils that we mentioned, one with 70 millimeters and the clay with 150. Let's assume effective wood zone of half a meter. We're in tuber initiation stage. Our daily ETC, daily plant use is 3 millimeters per day, 20% depletion threshold. This is the case here we've mentioned. And we are working with sprinkler or rain gun irrigation. We wet the entire surface. So doing all those calculations, you can do it at home if you really have the time. At the end of the day, we're talking about 7 millimeters or 10.5 millimeters of available water. So if my daily consumption is 3 millimeters per day, I divide it by 3, then I need to irrigate on a sandy soil every 3 days. Let's go to the clay soil, okay? Same numbers from 75 to 60. 75 is my field capacity, 75 millimeters of water like we calculated. 60 is 20% of it, so I have my gap, my availability of water is 15 millimeters. For a daily ETC of 3 millimeters per day, then I need to come back and re-irrigate every 5 days. So if I'm using a rain gun, if I'm using a pivot, flood or drip, doesn't matter. If I go over those 5 days, I'm starting to go below my depletion threshold and start to lose yield and profit. This is how it looks. It's a schematic graph, okay? For the ease of the calculation, on the left axis, we're talking about soil water in millimeters. And on the right axis, we're talking about either irrigation, rain, or ETC, daily ETC, okay? And this is 20 days, just to make the calculation easy and more modified. So let's say on day 1, we have 20 millimeters of rain, the green bar over here. This is field capacity, and this is my refill point. And I start, this is my soil water content. It goes all the way down because of daily consumption. And after 5 days, I need to irrigate. I'm getting close to my depletion threshold. Boom, apply almost 20 millimeters of irrigation, go back to all the way back to field capacity. I wet the entire area. Then I count another 5 days all the way down. If I go below, I don't have my machine gun, my rain gun, sorry, ready. I'm starting to lose yield. This is clay soil, 4 irrigations. If I'm talking about a sandy soil, or like sandy loam or something even more light than this, again, same amount of rain. It can be an adjacent, same phenological development. I lose 3 millimeters of the crop transpiration. After 3 days, I go below, need to go back and re-irrigate, and then a cycle of 3 days. If I grow potatoes on a light to medium soil, then I should be taking this into my consideration of 6 irrigations of 12 millimeters. Let's talk about the drip irrigation, for example, same conditions as you can see here, but I can wet only 50%. I don't wet the entire surface area. I wet only the ridges, only the parts that are essential, where the roots are, where the tuber are. So what I do, it's a little bit different calculation. Numbers are pretty the same, but as you can see in this graph, okay, I can lose my consumption. I start at field capacity, but when I cross depletion threshold, I can irrigate a much lesser amount of irrigation. I don't go all the way back because I don't wet the entire surface. I'm always around field capacity. We will see a graphic example very soon. Okay, I'm just around all the time around my depletion threshold with a small doses of irrigation, but I wet only 50% of my wetted area, and I can be more accurate with the water, also with the fertilizer, especially the nitrogens, that I can be more fertilized because around the plate, we will see a sensor example. Around the plate, I'm always around field capacity. I just don't wet the entire surface. So it's a different approach for irrigation. And now we will continue to the last part. Which the last part is digital solution monitoring. And we know that soil monitor is highly crucial in irrigation scheduling. You can build a water board if you know your soil type and your crop coefficients and phenology. Sometimes localized adjustment are crucial. So if you install your soil sensor, make sure you install them. It can be a pinpoint sensor like here that you install them at the center of the ridge. If you're working with drip and your dripper is over here, so very close to the drip. Also, a method that we develop when irrigating potatoes with drip irrigation is beside the main root zone sensor and the deep, a little bit slightly, the end of the root zone sensor, we also place, we call it the policeman. It's at the side of the ridge, and we want to see that when we irrigate, we wet the entire ridge. Again, we don't have to wet the sidewalks, only the ridges are getting water and fertilizers. But once we place this sensor, we know that we are in the right place, we irrigated enough. We also like to use the solution of installing a profile sensor that goes all the way down, 50, 60 centimeters down. And we want to see that the entire ridge, where we know the roots are wetted. Also, the combination, installing a profile sensor and a pinpoint sensor at the side of the ridge is a guarantee for success, because you know you have wetted the entire wetted area all the way down and all the way lateral. So this is the main combination. And this is how it looks like. This is 2 pinpoint sensor. The red line is the shallow one, and this is the deeper one. Those bars are the irrigation events. You can see it's a sandy loam soil from Mexico, uploaded we have alongside with PepsiCo, and all the way down you can see the irrigation event. We get the entire ridge wet. Consumption day 1, day 2, day 3, boom, re-irrigate all the way back and all the way down. This is just an example of how solutions of monitoring can help you really detect and improve your irrigation. This is perfect irrigation, but if I see a decrease or increase, then I would change maybe my crop coefficient, maybe my irrigation interval. It's a different discussion that one day we might talk about it. Also, a lot of softwares that are available today. This is a software that we work with. It's an irrigation scheduling software that basically is based on the principles that I mentioned. It takes your local climate, or it can connect to your weather station. And all we need to know is your planting date and your soil type. And it gives you irrigation scheduling of when to irrigate and how much to irrigate by millimeters, by inches, or even by time, if you know your irrigation rate and so on. So this is digital tool, which is very beneficial for irrigation scheduling. The last one, remote sensing, which is highly applicable for potatoes. You can see seed, emergence, establishment, vegetative growth, the reproductive stage, and the canopy senescence. And you can develop a benchmark and you can say, okay, my variety should be, I'm after 70 days, I should be at an NDVI of 0.65, but I'm on 0.4. So something's wrong. Maybe I need to push my crop a little bit forward. And we use it a lot to correct our irrigation scheduling methods. And this is from my side. This is also the opportunity to thank the platinum partners of the World Potato Congress and the silver sustaining partner. And this is from my side. I will try and answer some questions now that are in the chat. Okay, one question that we've been asked, two questions. I will read them out loud. This comes from Monica. She's talking about the configurations of the drip, 1 and 1 or 1 to 2. I will do it shortly. I will do it shortly. I will do it shortly out loud. Really, the benefits, if you are using 1 on 1, if you have a light soil, then you cannot use 1 to 2. If you have medium soil and you are going processing and your main issue is yield or uniformity or quality, then 1 on 1 is the perfect solution because you have the ability to deliver not just water, but also nutrients in the right timing. During, for example, in seed potatoes, we can use 1-1 and we can apply phosphorus during initiation stage and get a lot of good results from it. 1 to 2 is very common in places of when you have, for example, we have a lot of 1 to 2 plots in north of Europe or in Canada that they have rains during the growth season, but they have sometimes they can have 10 days, 20 days between each rain event, and they are starting to go below the depletion threshold. So in that case, you want to apply with a rain gun sufficient irrigation. But if they have a lot of plots or they have too many times because they have to cycle it every 5 days, then drip that can be easily automated or easily operated, so they prefer to do it with drip. But I can expand maybe on private mode later on about it. I was asking about rodent issues, and I will answer not on on-surface irrigation, no rodent issue. On subsurface drip irrigation, sometimes there can be a rodent issues, and there are ways to deal with it. Maybe this is not the time and place to discuss it, but there are methods when burying a subsurface drip irrigation below 30 centimeters, it can happen, and we have the abilities to perform with it. How can we review the presentations? Then the World Potato Congress will address you and assist you with getting this presentation and review it. This is for me, Johannes, who asked. Dennis Buckley is asking, what type of sensors do you prefer for measuring soil moisture, capacitance probe, TDR, or what? And I will answer that. I think TDR are more accurate, but they tend sometimes to be more sensitive, I would say, and usually they are more expensive. We work two probes I mentioned, they are capacitance probes, and they are very robust. You can throw them in the field, sometimes tractor, it rains sometimes, people are working, and they are accurate enough, and you've seen the graph, they are accurate enough in order to give you the data corrected. It's always a matter of value for money and so on. Dennis Osby is asking, how are you removing the TWD on green harvested chippers with full canopy before harvest or during, and how is the TWD removal managed? Well, Danny, every issue is different. Okay. But I will answer this. If you are working 1 to 2, drip to lateral, then no worries. You have a big time window to withdraw before, prior to harvest, to green harvest, to withdraw the drip. Doing it with this is 1 to 2. This is easy, and we have a lot of success with this. Doing it on a 1-to-1, sorry, doing it on 1-to-1 is a different thing. And again, you need to do some extra management with your recoil machine, but usually you do it very clean, a very good pace. You just withdraw it. Sometimes you need someone maybe to walk after the machine just in case you want to fix something. But usually I don't familiar with any problems of withdrawing, recoiling the drip in one-on-one position. These is the questions that were addressed. And I think I will collaborate with the World Potato Congress in order to see how this presentation is being spread out. And I'm very happy that you people want to do it. And I think this is the time to thank you and to wish you a good morning and good afternoon, good evening, wherever you are. Thanks a lot.